Hello, this is IE5320, Modeling and Analysis of Manufacturing Systems. And today we're going to do a course overview during this session. My name is Eduardo Perez. I am an associate professor in the Ingram School of Engineering in the Industrial Engineering program. And I'm going to be your instructor this semester. So I hope we have a great semester. You're going to learn a lot of things. And always remember that feel free to ask questions. Thank you. So the first thing I want to do is to make sure that you're in the right place. So make sure that you are in the right class section. We have only one section for this course, so it's IE5320. So if you're registered for Modeling and Analysis of Manufacturing System, you're in the right place. Again, I'm going to be your instructor, Eduardo Perez, Associate Professor. And we're going to be meeting in the Ingram Hall in room 4106 on Mondays and Wednesdays from 2 p.m. to 3:20 p.m. The agenda for today's session is the following. We're going to start with an introduction for this course and motivation. Then we're going to discuss the syllabus, which is already available in Canvas. You can download that one. It is available electronically in the Canvas site. And then I'm going to transition to an introduction about myself, what things I do in addition to teaching, and then we're going to discuss email communication, and finally we're going to have time for other administrative issues. So let's get started with the course introduction and motivation. And since our course is the title of this course is Modeling and Analysis of Manufacturing Systems, I want to start by defining those three major concepts that are part of the title. So first one is modeling. Modeling is the development of an abstract representation of reality that describes and represents a system. So when we discuss about modeling, we are basically trying to abstract the most important characteristics of a system and represent them in an abstracted way. Meaning it could be a computer program, it could be a mathematical model, and so on. So that's what we are trying to do. We're trying to develop this abstract representation of reality in which we account for the most important components or characteristics of the system. The analysis is a detailed examination of elements or structure of something, typically as a basis for discussion and interpretation. So from our perspective, we're going to be developing these models that are representative of an actual system. And then we're going to run some experiments. And then based on the results that we obtain from the system and the experimentation, we're going to do some type of detailed examination. What these numbers mean? What are the meaning of these numbers? And what type of insight I can gather from these numbers? And then finally, the system is a set of connected things or parts forming a complex whole in particular. So a system, not only in manufacturing, but in other settings as well, will have multiple components that when you put them together, they have a purpose. They're trying to achieve an objective. So it's a set of connected things or parts forming a complex whole with a particular objective. So in this course, we need to treat manufacturing as a science. And why science of manufacturing? Well, there's too many things happening in industry right now. There's confusion about too many revolutions. So if you're familiar with industrial engineering or manufacturing, mechanical engineering, you know that there are many things that you are encouraged to learn. And there are things like Six Sigma, lean manufacturing, just in time, and so on. So there's a confusion about when to use, what to use, why do we need to learn all these things, what is the purpose. So when we define a science of manufacturing, we're trying to provide some type of structure. Okay, so we don't want to just be guided by these cell glitz over the substance. So we want to understand what is the substance behind all these revolutions. There's also confusion in academia. many faculty members that perform research in manufacturing, they are focusing mostly on the methodology itself and not the actual problems that are happening in manufacturing. And there's a multiple and very different methodologies that are typically taught. So there's a huge variation in what is taught in different universities. So there's a need for consistency. So in this class, we're going to be guided by concepts that are put together that define the science of manufacturing. So let's talk about this simple example. So for example, we can use science to answer questions like this one. So for example, if you have a requirement that asks you to produce a car with a mass of 1,000 kilograms that can have an acceleration of 2.7 meters per second square, which will take the car from 0 to 60 in 10 seconds. And it's also required that you use an engine with no more than 200 newtons of force. So the question is, can you do it? Well, we have science that can tell us that there's no way that we can do that, right? Because the formula for force equals m times mass times acceleration, and when you put those two together, 1,000 times 2.7 meters per square over second square, there's no way that that's going to be equal to 2,700 newtons, which is not equal to the 200 newtons that you're required to design the car for. So we can use science to make decisions and to make judgments about manufacturing questions. In the same way, from a manufacturing perspective, we can have a requirement to design a factory that produces 3,000 units per day with a lead time of no longer or no greater than 10 days, and with a service level percent of jobs that finish on time of at least 90%. The question again is, can we do it? The answer is, who knows? So we need to define these concepts in order to make sure that make decisions that can help us answer these questions. So here's a graph that can show us how the lead time in days is changing. The lead time is the time between the initiation and completion of a production process. How the lead time in days changes as we increase the service quality of service in percentage, which is the x-axis. So as you can see, and then we have a production level that is 2,400, 2,600, 2,800, and 3,300, or 3,000 units per day. So so you can see that as we increase the production, let's say 3,000 units, in order for us to meet that lead time that was requested, which is 10 days, it is impossible, even at a 76% quality of service or service level in percentage. So you see that purple line at the top, the lead time starts at 14, and that's with a 75% of service level. And as you increase that service level to 90, 97%, you see that the lead time goes way higher, almost 21 days. So using this information, we can make sure, or we can make decisions, or we can provide feedback, insight in terms of how possible it is for us to make a design in terms of a manufacturing facility. If we want to meet that lead time of 10 days, you see that the production level should be around 2,400, which is the red line. And you can see that with a lead time of 10 days and a 2,400 production or units per day, we can reach the 97% service level within 10 days of lead time. But that only happens if you reduce the production or the number of units required per day. So in this slide, I discuss the goals of the science of manufacturing. So we want to have some tools, which are, there's a group of descriptive models, prescriptive models, and solution techniques that we're going to use. We're going to use some terminology. We're going to rationalize the buzzwords, recognize the commonality across environments, and then we're going to provide some perspectives in terms of basics, intuition, and synthesis. Okay, so again, we go back to the concept of science, nature of science, and the purpose is the grand aim of all science is to cover the great numbers of empirical facts by logical reduction from the smallest number of hypotheses or axioms. And that's a quote for Albert Einstein. So what are the steps? Well, we will start with the observation, then we follow with the classification, and then using that information, we can create a theoretical conjecture, and then we do some experimentation for verification or refutation, and then we repeat until we can get the insights that we need. Another important concept that we have to have a good understanding is the systems analysis. So systems analysis is a structured approach to problem solving that involves first the identification of objectives, what you want to accomplish, measures for comparing alternatives, and controls, what you can change. And then the generation of a specific alternative. Then number 3, the modeling, which is some form of abstraction from reality to facilitate the comparison of alternatives. And the optimization, at least to the extent of ranking alternatives and choosing the best one in terms of trading off. And then iteration, which is going back through the process and new facets arise. Okay, so this is the system analysis. We identify these objectives, we generate some alternatives, we do some modeling analysis, some optimization analysis, and then we perform this. As we learn from the system, we have new facets that might need some additional study, and then we continue performing this analysis until we get to the final point. So in this slide, I show what is called the system analysis paradigm, which relates the real world with the analog world. Okay, so if you look at the left side of the slide, we start with the conjecture objectives, verify constraints, and identify alternatives, which is connected to the analog world through the operation analysis, which use measures of effectiveness, specify parameters and control, model interactions, and verify and validate the model. So then we follow with the compare alternatives, choose policies, and ask what-if questions. That is connected to the system design, which compare controls, optimize controls levels, and perform some sensitivity analysis. And then after that, we provide feedback to the step, and then we proceed with the implemented policies, train the users, fine-tune the system, which are all part of the implementation. And then we do an evaluation of the system performance, look for oversights, and identify future opportunities, which is part of the evaluation. And in the system perspective, that will include the validation of model predictions, question assumptions, and identify other controls. Some additional information about general measures and objectives. The fundamental objective is the elementary starting point, the source of agreement. For example, make money over the long term. And then after that, we have a hierarchy of objectives, which are more basic objectives that support the fundamental objective and closer to the improvement policies. And then we finally have the trade-off, which are the objective conflicts, in which we need models to compare the different alternatives and then choose the best one. So here's an example of what we trying to represent as hierarchical objectives. So as you can see at the top, you have the high profitability, and then you go down and how this translates into the outcomes that you can achieve. So for example, if you look at the low unit cost, we can find high utilization, low inventory as associated as minimizing the cost, and also the less variability. So high utilization means that you are using your resources, so there's no bad utilization of your resources, the staff and the machines. You don't have machines waiting, idle. You don't have people idle. So that translates into savings. And low inventory, because you save space. If you don't you don't have extra space that is unused, that typically costs you money. So if you keep a low inventory, then you don't have to spend much in warehousing and so on. And then in terms of high sales, you go to high inventory, more variability. In terms of products, so if you have more products, then you can address, or you can get to more people, sell more stuff to people. Fast response meaning that if a customer makes an order, can you satisfy that order quickly, and so on. In terms of corporate measures and objectives, the fundamental objective is to maximize the wealth and well-being of the stakeholders over the long term. That from a corporate point of view. The financial performance measures are the net profit and the return of investment, and the components are the revenue, the expenses, and the assets. From a plant or manufacturing plant perspective, the measures and objectives. Measures are typically the throughput, which is the product that is high quality and is sold. Cost, the operating budget of the plant, and the assets are the capital equipment and the work in process, WIP. The objectives are also to maximize the profit and to minimize the unit costs, and also the trade-offs we would like but can always have is have a high throughput with low cost and low asset or capital equipment investment. Some of the system analysis tools, we have the process mapping, which allow us to identify main sequence of activities, highlight the bottlenecks, and clarify critical connections across business systems. And we also have workshops, which provide structured interaction between various parties, many methods such as nominal group technique, Delphi, and so on. And roles of moderator and provocateur are critical in generating the discussion. In terms of system analysis tools, the continuation of the ones that we started in the previous slide, we have Conjecture and Refutation, which promotes group ownership of ideas, places critical thinking in a constructive mode, and everyday use of the scientific methods. We have to keep that in mind. And we also have the modeling, which is always done with a specific purpose. Value of model is usefulness, so meaning that this is something that people can use to get insights. And remember that modeling is an iterative process, so you will not get the model from the first try right. So you have to go through the iterative process until you make it realistic and useful. So why we need the process mapping? For example, the North American switch manufacturer recorded 10 to 12 week lead times in spite of dramatically reduced factory cycle times. So here we have some percentages in terms of where the lead times were happening. I see 10% sales, 15% order entry, 20% engineering. And you see that only 5% was related to pre-manufacturing and manufacturing. So even though they were able to reduce the lead time in manufacturing process, they still were facing issues. And the reason why is because the lead time reduction must address the entire value delivery system. Not only the manufacturing part, but also all the things that are connected in order for you to be able to deliver the product. So the process mapping activities, the purpose is to understand the current system by identifying main sequence of activities, highlighting bottlenecks, and clarifying critical connections across business systems. There are multiple types of maps. For example, the assembly flowchart, which is a diagram of activities to assemble a product. process flowchart, which is a diagram of how pieces of system interrelate in an organization. The relationship map, which is a diagram of specific steps to accomplish a task without indication of functions or subsystems. And the cross-functional process map, which is a diagram of specific steps to accomplish a task organized by function or subsystem responsible for the step. So in this slide, we show an example of a assembly flowchart. So as you can see, you have the layout of the manufacturing line, and you have the processes, the machines that are used, and all of them marked with using the legend, right? So you see that at the bottom. And we have two cells. In this case, we have the flow with that continuous line, and then we have the test bay at the end of the second cell. So this is an example of an assembly flowchart. In this slide, we have an example of a process flowchart. So this is using the typical definition of the figures, right? So diamond is a decision, the rectangle is a process, and so on. So we follow the definition of the flowchart symbols. And as you can see here, there's a process flowchart for order entry. In this slide, we have a sample relationship map. So typically what you see here is the connection between the processes and the operations in the facility. So we start with the production control, and then we have some steps in the manufacturing process that are happening, and those move after processing is completed to the warehouse, and from the warehouse to the customers, and so on. And then finally, we have a sample cross-functional process map that is showing you the time at the bottom, and then the different areas of the company that are involved in each piece of the relationship or the process map. So in conclusion, after this introduction, we have a science of manufacturing, which is important for practice, provide a structure for operation management education. We're going to follow a systems approach, one of the most powerful engineering tools and a key for management skills as well as re-engineering. And then modeling piece, which part but not all of the system analysis, and is key to a science of manufacturing. And we need more descriptive models for the analysis. So now we're going to go over the syllabus. In this slide, I'm showing my information for electronic communication. The best way to contact me is via email. So my email address is listed here. And I'm also sharing with you some of my social network usernames. So in case you want to connect with me, those are the best way to connect with me via social media: LinkedIn, Twitter, and Instagram. Typically, I don't use this social network for anything else than sharing information about internships and job opportunities. So if you want to get those, you can follow me in any of those. And then I'm going to hold virtual office hours this semester. The passcode and the link is available in this slide and also in the syllabus, which is available in Canvas. And the office hours are going to be on Mondays and Wednesdays from 9 to 10 a.m. and from 3:30 to 4:30 p.m. or by appointment. So in terms of the course objectives, the objective of this course is to give the students experience in modeling, solving, and analyzing problems. Emphasis will be stressed on theory, applications, and computer usage. So by the end of the course, the students should have developed the skills to build analytical and simulation models that can assist in the design of new and improving the operation of existing manufacturing system. Also, learn how to effectively apply the techniques for analyzing and optimizing manufacturing system. Understand the latest manufacturing design and operational issues that can be addressed by manufacturing system models as reported in case studies available in the published literature, and become familiar with commercially available software used for modeling and analysis of manufacturing systems. How are we going to pursue these objectives? Well, 2 times a week, this class will meet for about 80 minutes, and beside lectures, a good bit of classroom time will be devoted to answering questions, working examples, and labs. 4 exams will be given to assess the student comprehension level of the course material, and a project will be also assigned. In terms of the textbook, we're going to be using factor physics and simulation modeling analysis with ARENA as our course textbooks. These are not required. I'm going to be sharing some of the information with you in class. And then we have some additional reference listed here. So the textbook is recommended. You don't have to buy it. But if you want to have it with you, then these are the 2 recommended books. And the course website are the Canvas. So we're going to be using Canvas for this class. The exam schedule is listed here. So we're going to have 2 exams that are going to be based on theory. Those dates are listed there. The first one will happen during the class period. The second one will be on the day of the final exam. And then we're going to have 2 simulation exams. These are computer-based. And those are going to happen during the class period. In terms of homework, quizzes, and labs, homework will be assigned. Only some of the homework assignments will be collected for grading. I will announce which assignment to be submitted, and those assignments that you're not required to submit will be evaluated with a quiz. Assignments are due at the beginning of the lecture. Submitted work must be professionally presented without exemption. No late work will be accepted. Makeup exams will not be given. Any student who fails to submit a graded assignment on time will be awarded 0 score unless there is a legitimate medical emergency reason and valid documentation is furnished. Labs are practice problems assigned during the class period. And in this class, those are going to be mostly computer-based labs. The grade distribution is listed here for this class. So homework 10%, theory exams are 20% each, and the simulation exams are 10% each, and the project is 30%. The course grade follows the standard curve. Without the final, grades are truncated, thus 89%, 89.99 is a B without the final. If a test is missed, you must have a written authorized excuse. If possible, please let me know before the test. Otherwise, I must be notified within 2 days of your return to school. Missing an exam or quiz without a written authorized excuse will result in a 0 grade for that item. Any disagreement regarding the grade received or any material must be discussed within 1 week of the return of the graded material. So if I submit I return the graded material to you today, then you have 1 week to ask questions about that. After that week, I'm not going to be answering questions about that graded material. Attendance and diversity, equity, and inclusion. Attendance and participation in lectures are encouraged. However, no grade will be given for attendance. If you come to the classroom, do not arrive late or leave the classroom during the lecture unless it's an emergency. In terms of diversity, equity, and inclusion, in this course, we are committed to learning together to think for ourselves. So, pursuit of this idea relies upon civil behavior towards all course participants such that all have an equal opportunity for learning regardless of gender identity, gender expression, race, color, national, or ethnic origin, religious belief, political affiliation, age, marital status, sexual orientation, ability status, veteran status, familiar background, or any other reason not related to intellectual merit. Participants in this course are expected to assist in sustaining this inclusive community. Health, wellness, and safety. So this is a very important topic that we need to discuss. This is information that you have received already via email. So we are going through a pandemic right now. We are encouraging students to follow these 5 steps to continue our face-to-face experience. So we are encouraging students to get tested, also to stay home and get tested if you develop some cold-like or other COVID-19 symptoms. We are also asking them to report to vocab trace if you test positive for COVID-19 or have had any close contact with someone who received a positive test result. Reporting information can be found on the Texas State COVID-19 Testing Reporting and Response Steps webpage, and the link is there. Isolate if you test positive for COVID-19. Stay home and away from others for 10 days from the start of symptoms or the positive test if you have no symptoms. Quarantine if you have been identified as a close contact and stay home for the prescribed time period. Okay, so connected to this, that's why I'm going to be posting my lecture videos in Canvas, and that's why I'm not going to give any attendance grade for the class. So you have the flexibility to stay home and watch the lectures, and also work on the assignments and the labs if needed. So you have that flexibility. Face covering and vaccination protocols. Every member of the university community is urged to get vaccinated and wear a mask indoor, regardless of vaccination status. Together, we can reduce the risk of infection and transmission of COVID-19 and live out our shared values of respect and compassion. I want to make a special request, not as an instructor or as a professor. I'm making this request as a parent. I have 2 little girls that are under 12 and they are not vaccinated right now because they don't qualify for the vaccine. So I don't want to get infected in the university and then bring that to my house. So please, I really encourage you that at least during my class to wear a face covering and to continue to help us contain this virus in our campus, because that's the only thing that is going to keep us face to face throughout the semester. So please, this is a personal request. If you can wear a face mask or face covering during my class time, I would really appreciate that. Academic integrity. It is the responsibility of the students and instructors to help maintain scholastic integrity at the university by refusing to participate in or tolerate dishonesty. You can refer to this website if you have questions. In my class, plagiarism will not be tolerated and will result in an F in the course. Also, if you have any type of disability, please send me an email or schedule a Zoom call with me, and we can talk about the accommodations that you need. In this slide, we have the topical outline for the semester. So if you want to go be proactive and read some of these book sections before coming to class, that would be great. So I have posted the topics that will be covered per day, and also the sections in the textbook that are related to that topic. In this part of the lecture, we are going to talk about the email communication. Part of the idea of this lecture is to help you develop the professional way of sending emails. So when mailing the teacher, now you're a student, but in the future you're going to be an engineer. So this is very important. It's going to be very relevant for you. So always include your full name and course, include your class and what the email is specifically regarding in the subject. So here we have an example. So in the subject, this is IE5320, question about homework 3. I need to know the class. I need to know the course because I'm teaching another class with a different subject. And if I don't, and if you ask me a question and I don't have the information about which class you're referring to, it's going to be very difficult for me to answer that question. And then we go through this process of me asking you some information that you can provide me from the beginning. The basics, you have an example here. So you provide the name of the instructor, and then you state the question, and then you put your name at the end. Try to keep the email brief. Respond to emails within the same time span you would do for a phone call. Most of the email communication that you're going to receive from my part is going to be sent to the entire class. If I send you an email specifically to you, make sure that you answer that email quickly because that means that something happened. Okay, so check for spelling, punctuation, and grammar errors before clicking send, and use a professional font, not decorative. In terms of the attachments, basically what I want to say is if you're going to submit a document, please use the PDF format and also provide a name that could be easy to, like if I save it and I read the name of the file, I know what the file contains. Good topic for an email. You should email your teacher if you have an easy question that can be answered in a paragraph or less, or you have an assignment that you are allowed to submit via email. Bad topics for email. There are some rules that is best to follow, such as don't try to turn in an assignment through email if your teacher has specified against it. If you had to get an extension for an assignment, please let's schedule a Zoom meeting and let's talk face to face. Don't bring up any topic that will require continuous conversation because if things become heated, there's a large risk for misunderstanding. So in that case, it's better to talk face to face. So the last part of this lecture is the instructor introduction. So a little bit about myself. I am from Puerto Rico. I did my undergraduate degree in the University of Puerto Rico in Mayagüez. Graduated in 2004 with a Bachelor in Science in Industrial Engineering. After that, I worked for a financial institution and then moved to Texas to pursue a PhD also in industrial engineering. Graduated in 2010. Also did a postdoc at Texas A&M University and finished that postdoc in 2012. And after that, I transitioned to Texas State University. So as I mentioned at the beginning, we have a component. We faculty members in the industrial engineering program. We have a research component. In addition to teaching, we do research. And I have a research lab You can find more information about my research lab in the English School of Engineering webpage. And there I have students working for me, graduate students and undergraduate students. And we do projects, research in healthcare systems, engineering and analysis of patient flow. Basically, we implement tools, we develop tools to help hospitals make decisions in terms of resource allocation, resource alignment, resource assignments, and so on. I also have a project that looks at the reliability analysis and maintenance decisions for wind energy systems. Currently, also have a project with the Department of Homeland Security that is on improving the passenger flow at the airport checkpoint terminals. And I'm actually looking for an undergraduate student to work with me in that project. I have a position, a paid position. So if you are interested in simulation modeling, specifically with Simio, you have experience, or if you are, if you want to learn, just contact me and we can talk. Also, I have a project with the National Science Foundation in which we are analyzing the data for Texas for the COVID-19, the number of cases, the number of deaths, everything. We have a database from the state, and we are currently studying some of the trends related to COVID-19 in the state of Texas. So I also have a position open for an undergraduate student. So if you're interested in data analysis, if you're interested in learning about the current trends in the state for COVID-19 and so on, we have a paid position also available. And finally, we have a project with the Texas Workforce Commission. This is not necessarily a research project. This is more a practical project in which we have students making reliability assessments for different products that are manufactured by people with disabilities in the state of Texas. So the project is basically looking at the reliability and the quality of those products, and we are comparing those with the leading brands. So for example, we are making tests for the reliability of pens, reliability of ink cartridges, reliability of gloves, and so on. So we also have some paid positions for that project. So if you're interested, you can send me an email and we can schedule a time to talk. So multiple opportunities. If you are interested in doing some research work or some additional practical work, looking to make some money, there's some opportunities in my research lab. Okay, so that's the end of the lecture. And now there's time for questions. So if you in the classroom, you can ask your questions now. If you are watching the video, you can send me an email with your questions and we can set up a time to talk.